So, if you got hit with this paper, I feel so sorry for you, but I'm going to go through some of these questions. I'm going to try and get through most of them, but let's see if we can do this in less than 10 minutes, okay? So, the very first question, 1A, asks you to solve this for x essentially here. So, you have to basically have this inequality, and you have to be careful in inequalities multiplying by any term that you don't know is positive or negative. Essentially, I mean x here. So we have to multiply by something we know is positive. Now, there are probably many ways to do this, but how I would like to do it is I will multiply everything by 2x squared. Now, the reason why I'm okay to multiply everything by 2x squared is because that's something that's definitely positive, regardless of what x is, because when I square x, it's going to be positive, and I'm multiplying it by a positive 2. So that's what I would suggest to do first. When you multiply each term by 2x squared, this guy is going to cancel with this guy. The 2 here will cancel with the 2 here, and this x here will cancel with one of the x's up there. So when we rewrite this, we're left with x squared times 1, which is just x squared, minus 2 times, or sorry, just 3 actually, because that's cancelled out, so minus 3, and greater than equal to, so we just have 2x times 1, which is just going to be 2x. So now I have an inequality, so now I'm okay to bring this guy over, because it's a quadratic. This is, if you know how to solve these, it might be easy now, but I'll do it anyway. So we have x squared, that becomes a minus 2x, and this becomes a minus 3. And we want to know where this stuff is greater than or equal to 0. So this is a quadratic equation here. So what I'm going to suggest to do here is find out where it's equal to 0 first. So let's think about this guy. Let's pause and think, where would this be equal to 0? And let's kind of factorize it out there. So this is equal to 0. If we factorize, we get x minus 3 and x plus 1. And that's going to give us an x equal to 3 or an x equal to minus 1. Okay, this is a quadratic graph that looks like a happy face, if you've ever heard that. Hopefully you have. And I'll sketch it here. So it has roots either side of the origin. So one at like minus 1 here and one at 3 up here. So it's a happy face graph like this. And it doesn't matter like that it goes through minus 3 there, but I'll just say it does anyway, right? So we're asked, where is this graph greater than or equal to 0? So it's greater than or equal to 0 when it's going off up here and when it's going off up here. So for all the x values that are above 3 and for all the x values that are below minus 1, that's when it is greater than or equal to 0. So actually, that's my answer is going to be easy enough here now. It's going to be x. When x is, it goes out this way, it's above 0, but we have the greater than or equal to sign. So when x is greater than or equal to 3, or less than or equal to minus 1. And that's your answer for the first part. So next question then says, well, x equal to half is a root of this equation here, so hopefully you can see it. So it says if x is a half is a root of this, show that k is equal to 17. Well, if x equals to a half is a root, we should be able to put in a half for each x term here. And we get something like this, half in for the x squared, and minus a 5.5 in for that guy with the 5 plus 6. And if we do all this and multiply it out, and just to save time, I'm not going to bother you should get an equation where you'll end up with, maybe I will do it. So we get 6 times, and we'll put in the half, and we'll put in cubed here. And that gives us 3/4 here. So plus a half squared is a quarter, so that's going to be k times a quarter, it's going to be k over 4. Minus 5 times a half is just minus 5 over 2, and we're just left with a plus 6 here. Let's add all these constant numbers without the k together first. So we get like 3 over 4 minus 5 over 2, and then a plus 6 equals, and we get 17 over 4. So we get k over 4. It's a plus 17 over 4 is equal to 0. Well, it should be obvious then that k is minus 17, so I'm happy with that. So we're happy we've showed k is equal to minus 17. You can keep going from there if you want. Now to find the two other roots. So the thing called the factor theorem says if x equals a half is a root, we should be able to find a factor from that. So I might switch to the other marker here. So essentially what I'm saying is if x equals to a half is a root, remember when we solved quadratic equations like a minute ago and we were able to get out to these solutions here? Well, if I brought that back in, I could make the factor x minus 3. So I can make the factor from this, but what I'm going to do first to suggest is this. I'm going to multiply across by 2 or bring the 2 over here, and I get 2x equals to 1. And then we can make the factor 2x minus 1. Okay, so like we change that out to x equal to half if we found it in a factorization problem. Now, if that's a factor and we know k is equal to minus 17, we should be able to divide this guy in to the full polynomial here, and we'll put all that stuff in. So 6x cubed, we know k is minus 17, and that's with an x squared, and we have a minus 5x, and we have a plus 6. So we should be able to divide him in if he's a factor, and let's see what we get. So let's think first about what do we multiply 2x by to get 6x cubed. That's going to be 3x squared. That gives us our 6x cubed minus our 3x squared. So I like to say draw a line, and we will change the signs here. So this comes minus, this now becomes a plus. They cancel. 17x squared plus 3x squared. It's going to give us a minus 14x squared. Bring down this guy, and we get minus 5x, and we go again. 2x times what gives us minus 14x squared? It's like minus 7x. Multiply him by the 2x, and we get minus 14x squared. Multiply him by the minus 1, and we get a plus 7x. We draw a line. We change the signs. So now we have, these are gone. Minus 5x minus 7x is a minus 12x. Bring down that plus 6. 2x times what is minus 12x? That's just a minus 6. And we get minus 12x, and then minus 6 by minus 1 is plus 6. Lovely. They cancel. So here's the answer when we divide it in. But of course this is a quadratic, so we should be able to further factorize this guy. Since it's 3x, it's going to have to be 3x and an x. And we're going to think about two numbers. So if we go two numbers multiplied to give minus 6, and we use the 3 to get to minus 7. So yeah, minus 3 and a plus 2. So these are the other two factors. I think the question says find the other two roots. So we have to find these as solutions. So we go 3x equal to minus 2. X is equal to minus 2 over 3. Or just simply x is equal to 3. So there's our other two roots there. That one. And the last one, oh geez, this is a killer question, this one. So this is probably the only one I've looked at. So, and I had to, I don't know what I've got this done in the time in the exam, but I probably spent 10 minutes thinking about this one. So, first off, the first one's easy, right? They tell you to use the change of base log formula, and really that's the kind of thing used to come up at all, but in the last few years it's come up a few times, and I used to always tell my students that this will never come up years ago, but in the last little while it has come up. So use the change of base to show this is true. Now, the change of base, you might think to yourself, well, how do we know to change which one? Well, if we're getting equal to 2, it should be kind of maybe a little bit obvious that we have to change this guy to log base 2, and that'll work better. But it kind of just works out when you do it. But I don't know how to explain it any better than that, but we're going to change log base 3 of 4 to log base 2 stuff, okay? So I'm going to write it over here. So log base 3 of 4 has to go to log base 2 stuff. If we follow the rule, it says that if you have log base A of some B and you want to change it to log base C stuff, just put the B on the top with and the A on the bottom. So I want to change it to log base 2 stuff. It doesn't matter what you want to change it to. You just have to put the B part, which is the 4, on top, and you have to put the A part, which is the base, on the bottom. So it changes to this kind of thing here. Okay, so I've put the 4 on top and the 3 on the bottom. So now I can change this guy out to this stuff here. So if I do that, that's going to give me, instead of log base 3, 4, I'm going to change that to log base 2 of 4 over the log base 2 of 3. That was multiplied by the log base 2 of 3. Now you notice that on the bottom I have a log base 2 of 3, and on the top they cancel, and this stuff should be equal to 2, it's saying, and I'm left with the log base 2 of 4 is equal to 2. And that's true. If you watch my video on logs, I like to explain it like 2 to the power of this stuff should give you 4, and that's correct. Or if you just put this into your calculator, you're going to get 2. Okay, here's the one, isn't it? Like, this one is just beast of a question, I suppose, you know. So it says use what you know to figure out what we figured out here. Okay, so this is what they want you to do. They're saying hence there is actually an identity that will help you solve this, but I'm not sure what it says in the marking scheme because I don't have the marking scheme to this. But the only way I can think of doing this, and I'm sure there are other probably people on TikTok that might solve this differently, but just let me show you the way I would like to do it. So we were told that log base 3 of 4 times the log base 2 of 3 is essentially the log base 2 of 4. Okay, when we like simplified it, it was equal to 2, which is equal to the log base 2 of 4. Okay? By that reasoning, we can take the last log base here and put it to the argument of the first one here. So for instance, these two terms here, let me just take these two terms here and say the log base 31 of 32 times the log base 30 of 31. By the same reasoning as this little identity we figured out from this one here, we can say, well, we can take the second base and say that's equal to the log base 30 of 32. Okay? So we know what these two things are equal to. Now, we now have these two things dealt with, and now we have to multiply the log base 32 by the log base 29 of 30. And we'd have to keep going for a long time. But let's look at this one with the same kind of identity we figured out in the first part. So now we can say, well, this is equal to the log base 29 of the second part of the log base 32. And now we can say this stuff now is cancelled out this guy. And now we can say what comes after him? Well, we still have the log base 29 of 30. And what looked to come next would be the log base 28 of like 29. And now we can say that's equal to, or sorry, this is 32. This is this answer up here brought over here. So we could say this is equal to the log base 28 of, again, 32. What they expect you, I think, to figure out here is to notice that we're just going to keep going down in the log bases to the last one. But the 32 is going to remain constant. So we're going to do this all the time until essentially we get in the end to the log base 2 of 32. If you keep that pattern repeats, and of course that's equal to 5. So yeah, if you got that out, fair play to you. You're nailed on for your H1. So otherwise, I hope that helped.